Hi everyone, welcome back to my channel. I'm Abhishek and in today's video we are diving deep into file handling in Python. We'll cover everything you need to know to work with files effectively, including how to open and close files in Python, writing and reading from text files, using the with statement for file operations, appending content to the existing files, working with file paths using the OS module. Handling file-related exception is crucial to ensure your program runs smoothly even when something goes wrong. Reading and writing binary files is essential, especially when dealing with non-text data like images and executables. Efficiently processing large data files can save you time and resources. We'll explore techniques like using line-by-line reading, chunk reading, and generators to handle large datasets effectively. By the end of this video, you will have a solid understanding of file handling in Python and be able to manage files in your project with ease. Let's get started. Now let's jump into the Jupyter notebook to write some code and see these concepts in action. Suppose I have a file named example.txt under users and files directory. To start working with files, you need to open them using open method. Open of, here we have to pass the path of the file, then the mode of the file. W means write. We are opening it for writing. Then it will return the file object. I'll collect it. Once we have opened the file, we can write into a file. Later, at last, we can close them using file.close method. This is how we can open and close the file in Python. Let us now create a file and write some content to it. Writing to a file is as simple as using a write method. Let's try to write a to-do list to a file and then try to read it back. First step is to write to a file. Okay, let me open a file. I'm trying to write to a example.txt file and then W is the write mode. It will return a file object. I'll collect it in a file variable, then file dot write of, we can write a content here. Line Python /n is for new line. Then we can write the next line, file dot write of, then the next line content, create some content, new line, close the bracket. After writing, then we can make use of close method to close the object, file object. Now let me try to execute it. See here. So have written two lines under example text. So let me open the text now. You can check that we have written two lines inside example.txt. Let me try to read it using Python. Read from file. So to read a file, what we have to do? First we have to open that file, right? After opening, we have to pass the mode. R is for read mode. Then it will return a file object. I'll collect it. After that, file dot read method to read the contents of the file. I'll pass it to content. I'll try to print. After printing, I'll close the file object. See, here it has printed the content of the example file. This is how we can use write method and read method to write and read. Using the with statement simplifies file operation by ensuring files are automatically closed. So if you see the previous example, here we have used the close method to close the file manually. If you use with statement, we don't need to close the file manually. It will automatically taken care. With open of file path, opening it for reading purpose as file. So file dot read will return the content of the file. I'll collect the content in a content variable. Then I'll print the content. This is how we can use the with statement for reading or writing a file. Let's you work with the file path. Let's list a file in current directory and check if file exists. So for that, we have to import the OS module. After importing, to get current working directory, os.get cwd. It will return the path of current working directory. I will collect it. Then I will print it. Current directory is this. So this is the current working directory. Then I will try to list files in this directory. To list files, os.list dir method. So to that I have to pass the path. This is the path of current working directory, and I'll collect the result here. So it will list all the files in the present working directory. I will print it. Files in directory. Files. Right. So we have this many files, right, in our current working directory. Then let us check whether any of the files exist or not. So to do that, os.path.exist is the function. Suppose I need to check whether my example file is present or not. So if you see here, that file is not present, right? Let me collect the result. Then I'll print it. Does file exist? File exist? No. False. Right. Suppose I'll give this one. I'll check whether that file is exist present in our current working directory. It will return true. That means the file exists. File operations can sometimes result in errors. Let's handle a common error. Let's trying to read a non-existent file. So what we'll get if you try to read the file which is not existent, we'll get a error exception, right? We'll catch that. Suppose I'll show it with open of file name. So this file is not present. I will try to open it. I'll try to read that file as file. I'll collect the content. So here I've tried to read the file which is not present. So if I try to execute it, I'll get file not found error, right? How to handle that? So we can use the try and except block. So try, inside that I'll place the code. If it raises an exception, which exception? File not found error, right? Then I'll handle it. I'll return file does not exist, right? See, file does not exist. Next is about reading and writing a binary file. Working with binary files is essential for handling non-text data like images, executables. So let's write and read the binary data. First, reading a binary data. So I have an image here. The extension of image is PNG. I'll copy the file path here. Okay, image path, and the name of the file is techjaala.png. Next, I will open this file, image path, and I am opening it for reading purpose. It is a binary file as file. I'll read the file content. After reading, I'm storing the content in binary content variable. Okay. So here I have the content of the file. Next, I'll try to write it to other location. Suppose I'll write it to the same location, okay, with a different name. So example.png. So the path is out underscore path. Let me open the file now. Which file? This is a file. We don't have the file now, but soon it will create. For writing purpose, write to a binary file as file. Later what we have to do? We have the content already. File.write of, see, this is the content. I'm writing that content to our new file. We don't have any file here. Let me execute this. Soon it will create a image file named example. This is how we can make use of file methods to read and write the binary files. Okay. Next, we'll learn how to process large files. When working with large files, loading the entire file into a memory at once can be inefficient and may lead to memory errors, especially if the file is larger than the available memory. There are multiple ways to handle this. The first way is to read the file line by line. Imagine there is a large file which has millions of records. So instead of loading it once to a memory, we have to collect it record by line, and then we have to process it. Next way to efficiently process large file is to read and process the file in smaller chunks. This method is more memory efficient and can significantly improve the performance. Let us look into the example now. This function takes two parameters: file object, which is the file we want to read, and the chunk size, which is the size of each chunk. By default, I've set it to 1 KB. This function uses while loop to continuously read from file until there is no more data left. Within each iteration of the loop, it reads a chunk of file with specified chunk size, that is 1 KB at a time. If there is no data, then it will return empty. It means we have reached the end of the file. The loop will then break. Right? The process function counts the number of lines in each chunk and prints it out. So let me run this now. So as you can see, processing chunk of size. So in the first iteration, it has processed complete 1 KB with 113 records, 113 lines. In the second iteration, it has processed 207 KB with only 21 lines. See, I have around 134 lines in my file, right? Next way is to use generators to process large files. Generators allows you to iterate over data without loading the entire dataset into a memory at once. This can be particularly useful for processing larger files. That means a generator in Python is a function that yields items one at a time, allowing you to iterate over large datasets without loading anything, means without loading everything into a memory. Let's look at this example function. This function takes file name as a parameter, which is the name of the file to be read. The file is opened with a with statement, ensuring it is properly closed after reading. Then the function reads the file line by line using for loop and yields each line at a time. Right? That means the entire file is not loaded in the memory. At particular point of time, only one line is in the memory. Right? And again, in this example, the process function simply prints the length of each line. Let me run it. So length of first line is 7, second line is 8. It just prints the length of each line. That's it. That wraps up our comprehensive guide to file handling in Python. We have covered everything from basic file operations to efficiently processing large datasets. If you found this video helpful, please give it a thumbs up and subscribe to Tech Jaala for more Python tutorials. Thanks for watching and see you next time.